All right, let's talk 1.5 day 2. Now, we introduced 1.5 when I wasn't here last Friday. All right, but let's go over, we're going to go a little bit deeper and kind of review it a little bit. Okay. Section 1.5 notes, here are goals. Excuse me. One little thing I want to comment on, if you ever see this symbol, you see me write this symbol means angle. Okay, it means angle. Now, we're going to talk about different types of angles. Okay, there's 4 different types we're going to discuss today. The first one's an acute angle. You've probably heard of acute angles before. Acute angles are an angle less than 90 degrees. Okay, it's important you put that degree symbol there. It's like a little 0, okay, or a little o, lowercase o. All right, so we got to put that when we're naming angles. Obtuse angle, you probably heard of obtuse. Obtuse is more than 90. And less than 180. Sometimes you notice on these degree symbols, I just put a dot. That's good enough for me. Okay. A right angle you've seen for sure. It's a 90-degree angle. Notice how I'm using the angle symbol instead of writing the whole word out. All right. A straight angle, 180-degree angle. A straight angle, it's a straight line. It looks like that. A right angle, we'll use this little box to mark it. Just a little box, that means right. Okay? Congruent angles are angles that have the same measure. We've kind of talked about that before. I'm going to go back here real quick and write something else down. You're going to see this a lot today and in the book and throughout this class. How you read this, that little M stands for measure. We say measure of angle A. Now, obviously, it can be any letter. It could be measure of angle B or ABC or DEF, whatever. But this little M, remember, means measure. It means measure. Okay? Angles, we're talking about having the same measure. Angle bisector happens when a ray divides an angle into 2 congruent angles. So here's my ray cutting it in half, and that makes these 2 angles. An angle trisector, An angle trisector is very similar. Tri just means 3. So I have 3 congruent angles. All 3 measures are the same. Okay, let's keep going. So these next 2 slides, we're talking about naming the congruent angles. Naming the congruent angles. So how do I do that? Well, I start here, outlining that angle. Then I outline the ray that bisects it. Okay? When I look at this NRP, when I look at NRP, I want to think to myself, what is the vertex? What is the vertex? The vertex is always this middle letter here. All right, that is our vertex. It's very important to know, very important to understand that R is the vertex. Okay, because when we decide which angles are congruent, we want to name the angles with the same vertex. Okay, the angles with the same vertex. So we have 2 options here. Don't write this down. Okay, this is one of our options. This is another option. Now, the first option has O as the vertex. The second option has R as the vertex. And since R was the vertex originally, this is the correct pair of angles. R is in the middle here. That means R must be in the middle down here. So this pair, not congruent. I cannot say that based on our information. Okay? Let's try this. SXW, X is our vertex. X is in the middle. I have 2 rays bisecting it. Okay? So now we want to name our angles that are congruent. Well, name three angles with a vertex of x. S, X, T. Congruent to T, X, V. Congruent to V, X, W. Those are our three congruent angles here. Okay? Let's keep going. Now, we know which angles are congruent. We want to name the bisector. All right, so here are two congruent angles there. It looks like the vertex is J. So I have three options: JF, JG, or JH. Okay, I want to figure out which of these three rays here cuts through the middle of my angle. All right, which one of those three is right in the middle? Is JF? No, JF is not. JH? No, it's JG, because JG goes right through the middle. Think about this one, POK to MOK. Notice here, J was the vertex, J was the first letter. Order matters. O is the vertex, O is my first letter. Well, it's got to be O to K. O to K. Now, for these next four, or next three at least, well, first of all, I want to make a change. This should be 2x minus 1. All right. I'm going to pause it. Okay, I want you to pause it as well. Try this problem. Try the problem. All right, so our gut instinct might be to set them equal. Okay, but I don't know if they're congruent. But I do know that this angle is right. I mean, it's 90 degrees. This one is 6x plus 3. This one is 2x minus 1. Well, if I add these two angles together, I will get my 90-degree angle. All right, so if I add them together, I'll get 90 degrees. I must add these two together. 6x plus 3 plus 2x minus 1 equals 90, and you should get x equals 11. Then we got to find the measure here, plug that back in, 21 degrees. This next one, I want this to be 3x minus 21. Pause it, try it. It's very similar to the last one. Give it a shot. All right, so again, this is very similar to the last one because this is 115, and I know the measure. I know what this is, and I'm giving the equation for that as well. So, having said that, I want to combine them and set they're equal to 115 degrees. All right, their sum is 115. I think x equals maybe 21. Yeah, 21, and that means DBF. Don't forget to find that. Oh, DBF should be 42. Just plug it back in. Last one, here we go. BF bisects. Whoops, let's use that. Let's use the red. BF bisects angle EBC. I know that this is 3x plus 2, and this is 12x minus 106. Remember, bisects means it cuts in half. It's right down the middle. That means these two parts are equal or congruent. So if our two angles are congruent, I can set these two equations equal. And solve for x. I think you get, pause it, figure it out. You get 12. And EBF becomes something, 38. All right, last one here. This is a little bit confusing. This whole thing is 12. B and C trisect this segment, which means trisect means, tri means 3. 3 equal parts, 1, 2, 3. Well, if there's 3 equal parts and the whole thing is 12, 12 divided by 3 is 4. So that's 4. That means A to C is 8. You're given that AB is x plus 3. But I know that AB is 4, so I replace this with the 4 and solve for x. We get x equals 1, and then I plug it in. 3 times 1 plus 6, which is 9. Is this a midpoint? Yeah, it is. Why? Because AB is congruent to BC. All right, there's a homework assignment on big ideas for tonight. Best of luck. Let me know if you have any questions.